Good afternoon, everyone. Welcome to this session. Today, I and my partner, Yao-Wei, will give a talk about Open-Falcon and explain why and how we built it. Let us begin with a little story. We tried to contribute a new data source to Grafana last year. But the Grafana team replied that, "I'm sorry, but we will not merge any new data sources unless they are very popular." So it's a little frustrated, you know. But very pleased that we have a lot of lovely fans that have been supporting us. They wrote many comments on this pull request to support Open-Falcon. Yeah, from that time on, I realized that it's our duty and the responsibility to make Open-Falcon getting better and better. Open-Falcon now is the most popular monitoring system. In China, there are hundreds of companies using Open-Falcon in production environments to monitor their servers and applications. First of all, I'd like to introduce myself and my partner. My name is Yao-Wei, Director of Didi Cooperation from China. Now I'm in charge of the Didi SRE department and focus on service reliability guarantee. Before that, I worked in Xiaomi. I'm the founder of the Open-Falcon software. I have been working on this project over 4 years. Yao-Wei, my partner, he is the director of Wifire Overseas R&D Center. Before that, he has successfully led the development of CD monitoring system in FastWeb. Now he is the co-maintainer of the Open-Falcon organization. This is the outline. We will talk about the motivation and why we built it, features and the highlights, architecture of how it works, comparison with other popular systems, community development. I guess that you might have a question. There are already so many outstanding open source monitoring systems. Why do we reinvent a wheel? And how does it become the most popular monitoring system in China? I joined Xiaomi at 2012. In the early days, we have been using Zabbix. However, with rapidly growing business and specific requirements, Zabbix is not enough to provide the support for performance, scalability, and users' efficiency. As we know it, Xiaomi was one of the fastest startups in the past year. When the server number grows up to 2,000, Zabbix is difficult to scale out. The peak is 5 Zabbix instances running online to support our rapidly growing business. It's very difficult to use and maintain. There is also a bit of learning curve of Zabbix. It's a big challenge, especially when there are hundreds of R&D colleges using it. User experience and user efficiency become the most important factors. We also have tried to use OpenTestDB and the InClassDB. OpenTestDB have a good write speed and can scale out easily, but the query performance is not good enough and not efficient. It's very slow when querying querying history data of long time span. Because OpenTestDB loads all historic data to memory from local disk. InClassDB has a lot of fancy functions and a very nice user experience. Its query language and real-time aggregator are very powerful. But InClassDB cannot well scale out. If you have large metrics, you have to set up several InClassDB instances and write data to different instances. It's not convenient to maintain. Given that, we decided to build a our new monitoring system. Open-Falcon aims to be an integrated and enterprise monitoring solution. When we were designing Open-Falcon, we want to achieve the following goals: well scalability, good performance, high availability, great flexibility, and user-oriented experience. Yeah, each module of Open-Falcon is super easy to scale up horizontally. When the data nodes scale up, the historic data will still be kept in balance automatically. Open-Falcon supports up to hundreds of million transactions per minute. You can easily scale up to support over 100,000 servers. Open-Falcon stores the data in local disk using round-robin archive format. Benefit from the round-robin archive format, the one-year history data of over 100 metrics could be retained in just a few seconds. Historical data is saved after sampling, which means that more time earlier, less data precision. Users can save more than 10 years historical data without consuming too much disk capacity. There is no critical single point of failure in Open-Falcon, and super easy to operate and deploy. In China, there are already hundreds of companies using Open-Falcon in their production environment. Open-Falcon has a built-in agent which will collect more than 400 server metrics automatically. Users can collect their customized metrics by writing plugins using any language, or just simply run scripts to relay metrics to Falcon-agent. The Falcon-agent is able to run in different platforms, which means you can run a Falcon-agent in macOS, Linux, or Windows. Also, Open-Falcon has abundant APIs. Every function of Open-Falcon can be manipulated through the RESTful API. You can easily integrate Open-Falcon into your own customized system. Open-Falcon is an integrated monitoring system, including metrics collecting, dashboard presentation, and alerting. It has a built-in portal that you can configure and manage your alerting rules. For easier management of alerting rules, Open-Falcon supports strategy, expression, template inheritance, and multiple alerting methods. When an alerting rule is triggered, you can also send the alerting event to third-party system, benefit from the Open-Falcon callback mechanism. With Open-Falcon, you do not need to register metrics in the server side. With the metrics pushed from agents, everything is done. Open-Falcon works well with Grafana as data source. It's very convenient for those users who prefer Grafana. The official built-in dashboard of Open-Falcon could be present multi-dimensional graphs, and the users can define their own customized dashboard or screen. The built-in dashboard is very fast and lightweight. Many Open-Falcon users are now using Grafana as the dashboard. These are some screenshots selected. Okay, in the next session, Yao-Wei will draw a more detailed picture of Open-Falcon to help you understand how it works. Thank you.
Thanks, Yao-Wei. Hello, everyone. I'm Yao-Wei. I will continue to tell you about Open-Falcon, especially focus on the architecture to let you know how these features are implemented. The diagram is the life cycle of a metric collected to storage path for judgment, dashboard presentation, and alert notification. The wall below are the components names. The name with red color are major components in Open-Falcon. As illustrated by the diagram, you can find that streaming processing is the way Open-Falcon handles the matrix. It's one-way data flow. The benefits of this design are simplicity and efficiency. The purpose of center status is to synchronize the state of the system. Center status mainly has two databases, Redis and MySQL. The figures show the dependency between each module and the database. The time is limited. I go beyond that. From this slide, you can see a lot of modules on the figure. It's Open-Falcon version 0.1. It's easier to extend, but annoying to maintain multiple repositories. So in version 2, we further integrate the module to simplify the architecture, and the system is finally divided into 4 blocks. The first block is dashboard, which is the front end of Open-Falcon, including management of alerting rules, users, and hosts. The second block is Falcon Plus, which is the block of Open-Falcon, the backend of Open-Falcon. It integrates all the modules in the version 0.1 by using a driver to launch selected modules individually. We still preserve good transitions. The third block is central status, which we have introduced in the previous slide. The next block is Falcon-agent. Sorry. This simplification doesn't sacrifice the flexibility, but allows us to put the contribution from community together. Additionally, Open-Falcon could easily leverage other open source projects like InfraDB, OpenTXDB, and Grafana. In summation, 6 design philosophy make Open-Falcon different. The first one, microservices. A microservices architecture encourages the decomposition of problems into small, isolated, and reusable chunks. A microservices architecture based on this concept, Open-Falcon monitoring system is actually a collection of loosely coupled services. The second one, push model. The difference between Open-Falcon and other monitoring systems is that we choose push model of agent to collect metrics instead of pull model. The advantage is that the new agent doesn't need to be reconfigured. It could be auto-discovered. By sacrificing some flexibility in this model, the implementation allows easier, faster, and more efficient execution. The third one, RD tool. Users often need to query hundreds of metrics, including data in the past 1 day, week, month, or year. How can data be all stored and keep systems responsive? It's a big challenge. In Open-Falcon, every time data is stored, sampling and archiving will be automatically executed. To avoid data loss, data archiving will retain 3 copies according to average, maxima, and minima sampling. With regard to the scalability problem of RD tool, we solve it by applying consistent hash algorithm. The fourth one, binary. One of Go's major features is the static binary. Because the entire backend of Open-Falcon is written in Go. So we can, the deployment cost is very low. The fifth, deployment. For easier agent deployment and management on a large cluster, we provide a tailor-made tool to keep the heartbeat with all agents, to ensure the agent can be always up and update on demand. The last one, Grafana. As mentioned earlier, we have provided corresponding data source API for Grafana, so that Grafana could be used as a dashboard of Open-Falcon. Okay, now we have compared the difference between Open-Falcon, OpenTSDB, and InfraDB. So my focus will be on Prometheus, because Prometheus are the most popular modern system, which has almost 10,000 stars on GitHub. We want to take more time to talk about Prometheus. You may be also interested in this comparison. So, what's the pros and cons of Open-Falcon compared to Prometheus? Our vision is that Open-Falcon establish an industry standard of monitoring. So our API provide all the operation in Open-Falcon. Developer can build their own monitoring system based on our API. So compared to Prometheus, Open-Falcon API is more complete. Choosing push model allows the system to have the ability to discover, which simplifies a lot of configuration. Even large-scale cluster, we could also use simple tag mechanism to manage it. The Open-Falcon configuration cost is lower than Prometheus. Prometheus could only scale out by sharding, but in Open-Falcon, almost each module could easily be horizontally scaled out with little configuration. Open-Falcon API exposes all operation of system. Based on that, you can develop your own dashboard. Compared to Prometheus, if the data are on the different node, you could only configure the data source for each Prometheus instance and display them on different dashboard. But because dashboard alert manager has higher degree of flexibility in alert management, such as grouping, deduplication, and silencing functionality. So this part, Prometheus wins. Open-Falcon provides the round-robin archiving mechanism to return the join data in a short time. Rendering and query performance of Open-Falcon is higher. With regarding to customized metrics, we only check if Falcon-agent receives the metric in the right format. So no matter what the language it is, the user just needs to write a script or program to send the data in a specified format. Hence, Open-Falcon has more moderate learning curve. The biggest advantage of Prometheus is that it has very flexibility query language. You can support a lot of combination of data processing methods. The query language could also be used to store data by recording rule and the alert configuration. Beyond that, Prometheus also supports the summary and historical metric type. In contrast, Falcon supports limited combination, such as sum, average, max. So this part, Prometheus wins. Next, let me tell you about the situation of our community. Various industries use Open-Falcon, including banking, cloud service, CDN, O2O, social network, entertainment, and so on. Thanks to the community, we now support 3 major operation systems. Also, Open-Falcon has many plugins. You could now install the plugin to monitor commonly used services. This is the information about our community. Welcome to participate in the development. In the end, I would like to sum up the presentation in a number. 100. More than 100 companies is using Open-Falcon. 40,000. Open-Falcon has been used to monitor more than 40,000 servers in one company. 400. Open-Falcon has more than 400 built-in metrics. 5,000. Open-Falcon has more than 5,000 community users by now. 3 seconds. The query and rendering can be completed in less than 3 seconds. The QR code shown on this slide is our project website. That's it. Thank you all for listening.